Hi, today we're going to be talking about the Pythagorean Theorem. There is a packet that goes with today's work. If you did not pick one up, please do so now. We have two goals for today. One of them is to use the Pythagorean Theorem itself to find missing sides in right triangles. The other is to use two theorems you probably never heard of, the converse of the Pythagorean Theorem and the Pythagorean inequalities theorem, to classify triangles as acute, right, or obtuse. If you saw the old Wizard of Oz movie, near the end, the wizard gives Scarecrow his brain, and the Scarecrow immediately screws up the Pythagorean theorem.
Back where I come from, we have universities, seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Comitiatum e Pluribus Unum, I hereby confer upon you the honorary degree of Ph.D.
Ph.D.?
Now the Scarecrow says the sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. And if you remember anything about the Pythagorean theorem, you know this is not even close to true. We're not talking about square roots. We're not talking about isosceles triangles. Let's just actually get to it and look at the Pythagorean theorem itself. Let's pause for a moment and give you a chance to get this down. Now remember that when we're talking about the legs of a right triangle, we're talking about these two sides. These two sides that are touching the right triangle. Those are the legs. And if we're talking about the hypotenuse of the right triangle, that's this longest side, the one that's opposite the right angle. This one has to be the side we're calling C. But the two legs, one could be A, one could be B. As long as you get the hypotenuse right, you're pretty good. So let's continue by looking at an example of the Pythagorean theorem in use. Here we've got a right triangle. We know the lengths of two legs, 4 and 6. We want the length of the hypotenuse, x. Well, the formula we want to use for this is the Pythagorean theorem. A squared plus b squared equals c squared. Let's plug in what we know. Our two legs are 4 and 6. Our hypotenuse in this problem is called x. This is not a hard problem to solve. I know what 6 squared is. 6 times 6 is 36. And I know what 4 squared is. 4 times 4 is 16. I can add these together and get 52. I can take the square root of this and get the square root of 52. Two important facts right now. One, we can simplify the square root of 52. We're not going to worry about that at this moment. We'll do it when we get back together. And two, you know that x squared equals 52 has two solutions. Square root of 52 and negative square root of 52. Well, our triangle can't have negative sides, so we're only working with the positive side. Let's take a second example. Again, we have a right triangle, and we know two lengths. In this case, we know that one of the legs has a length of 12, and the hypotenuse has a length of 15. There's no variable next to that third side. We're just going to call it x. Well, we know we're going to use the Pythagorean theorem here. A squared plus b squared equals c squared. 15 is my hypotenuse. That has to go where the c is. The 12 can go in either of those first two spots, and I chose to put it in the b spot. I know what 12 times 12 is. I know what 15 times 15 is. And now I'm going to subtract 144 from each side. Well, if a squared is 81, a is going to be the square root of 81. And I happen to know what the square root of 81 is. It's 9. Let's take a look at something different. The converse of the Pythagorean theorem. Let's pause so you can get this. This is a test that lets us know whether we have a right triangle. If a squared plus b squared equals c squared works, then we do have a right triangle. Let's test this out. Let's say that I've got a triangle and the sides are 8 and 11 and 13. Well, first, just to make sure I'm not tricking you, let's make sure that these numbers actually make a triangle in the first place. Let's use the triangle inequality theorem and check that the sides work. Look in your notes for the triangle inequality theorem if you don't remember. In fact, it is true. These three sides do make a triangle. So let's continue and check the converse of the Pythagorean theorem. It starts out looking the same, but we know all three sides. The longest side, 13, has to be C. So let's plug in. Is this true? I don't know. I know what 8 times 8 is. I know what 11 times 11 is. I know what 13 times 13 is. Is this true? No. No, it's not. 185 is not the same as 169. So no, these three sides do make a triangle, but not a right triangle. Let's look at another example. Let's say we've got sides 6, 8, and 10. Well, again, let's make sure this makes a triangle. We're going to use the triangle inequality theorem. And yes, it works all the way through. We do have a triangle. So let's see whether we have a right triangle. We're going to use the converse of the Pythagorean theorem. 10 is our longest side. That has to be C. Is this true? I don't know. I know what 6 times 6 is. I know what 8 times 8 is. I know what 10 times 10 is. And if I add them together, yes. Yes, it is true. Yes, this one is a right triangle. So what happens in the case that it's not a right triangle? The Pythagorean inequalities theorem will let us tell. Is it an acute triangle? Is it an obtuse triangle? Let's take a look at an acute triangle first. Pause for a moment. Now let's take a look at an obtuse triangle. Notice that in both of these equations, the c is written first. You don't have to write it that way, but this is the way it is in the book, and this is the way it is in my notes. So let's look back at example 3, which had sides 8, 11, and 13. We know it's not a right triangle. We got to make sure that the triangle inequality theorem gives us that it is a triangle. We did that already in example 3. We know these sides give us a triangle. Fine. What kind of triangle is it? Well, I'm going to plug in. 13 is our longest side. It has to be our C. Let's plug in. This should look familiar. We did these numbers already in example 3. 169 is less than 185. That means we're looking at an obtuse triangle. The last page of your work has problems. Please tear this sheet off your packet. Make sure your name's on it. Please make sure you hand it in. I will be talking with you soon. Have a beautiful day.